In the vast, ever-expanding frontier of human exploration, there exists a journey so awe-inspiring and monumental that it transcends the very boundaries of time and space. This epic voyage is none other than the extraordinary odyssey of Voyager 1, a pioneering spacecraft launched by NASA that has traveled farther than any other human-made object, carrying the hopes and dreams of humanity into the deepest reaches of the cosmos. Recently, Voyager 1 sent back a historic transmission to Earth that has ignited waves of excitement and curiosity throughout the global scientific community and beyond. At the heart of this remarkable message lies a discovery of unparalleled significance, an enigmatic object detected in the profound, uncharted depths of interstellar space. This mysterious revelation has reignited one of the most timeless and compelling questions that has captivated humanity for generations. Could this signal represent the long-awaited moment when we finally establish contact with advanced extraterrestrial life? For centuries, humankind has gazed up at the night sky with wonder, imagining the possibility of other civilizations thriving among the stars. Now, this revelation has brought those age-old dreams tantalizingly close to reality. Voyager 1's journey began decades ago when it was launched on September 5, 1977, as part of NASA's ambitious Voyager program. Its mission was bold and profound: to act as Earth's emissary, venturing beyond the familiar realms of our solar system into the vast unknown. While meticulously studying the outer planets and their moons, Voyager 1's remarkable voyage was marked by a serendipitous cosmic alignment. It set off just 16 days before its twin, Voyager 2, beginning a cosmic ballet that has unfolded for more than 40 years. What truly sets Voyager 1 apart from countless other space missions is its extraordinary spirit of communication. Despite its unfathomable distance from Earth, Voyager 1 maintains a steadfast dialogue with our home planet through NASA's venerable deep space network. This complex and powerful communication system allows Voyager 1 not only to receive commands, but also to transmit back invaluable streams of scientific data, bringing us ever closer to understanding the cosmos. As of the latest measurements, Voyager 1 is an astonishing 159.32 astronomical units AU away from Earth, equivalent to nearly 23.8 billion kilometers, or approximately 14.8 billion miles. This staggering distance makes it the most distant human-made object ever to voyage into space. Yet, despite this incredible remoteness, Voyager 1's instruments continue to operate, tirelessly collecting and sending back information that deepens our understanding of the universe around us. Voyager 1's primary mission was to explore the outer boundaries of the heliosphere, the vast bubble of charged particles and magnetic fields generated by the Sun. This outer boundary, called the heliopause, marks the frontier where the influence of our star gives way to the cosmic environment of interstellar space. Crossing this threshold in 2012, Voyager 1 became the first human-made object to enter the space between stars, beginning a new chapter in space exploration. What makes Voyager 1's mission truly remarkable is not only its groundbreaking discoveries, but also its extraordinary endurance. Originally designed to last only a few years, Voyager 1 has surpassed all expectations, continuing its interstellar journey for over 4 decades. Each day, it cruises through the void at an incredible speed of approximately 38,000 miles per hour, sending precious data back to Earth across billions of miles. Scientists anticipate that Voyager 1 will continue this historic mission at least until 2025, when its power sources are expected to diminish. Equipped with a sophisticated suite of 10 scientific instruments, including cameras, infrared and ultraviolet sensors, magnetometers, plasma detectors, cosmic ray sensors, and radio science equipment, Voyager 1 was built to be humanity's eyes and ears in the cosmos. These instruments have enabled the spacecraft to withstand the harsh and unforgiving conditions of deep space, while delivering an unprecedented wealth of knowledge about the outer solar system and beyond. Among Voyager 1's most celebrated achievements are its close flybys of two colossal gas giants, Jupiter and Saturn. In 1979, Voyager 1 made its first close approach to Jupiter, revealing breathtaking details about the planet's turbulent atmosphere, intricate ring system, and diverse moons. The spacecraft's instruments confirmed the existence of faint rings around Jupiter, previously only theorized, and uncovered previously unknown moons that added to our understanding of the planet's complex environment. A year later, in 1980, Voyager 1's encounter with Saturn provided equally stunning insights. It unveiled the intricate structure of Saturn's iconic rings, captured detailed images of its moons, and deepened our knowledge of the planet's magnetic field and atmosphere. These flybys not only revolutionized planetary science, but also inspired a new generation of explorers, scientists, and dreamers around the world. One of the most iconic moments in Voyager 1's journey came in 1990, when the spacecraft, prompted by the visionary astronomer Carl Sagan, turned its cameras back toward Earth and captured the now famous image known as the pale blue dot. In this extraordinary photograph, Earth appears as a tiny speck suspended in a vast cosmic ocean, a fragile and precious home floating in the immense void of space. This image remains a powerful symbol of humanity's shared vulnerability and interconnectedness, reminding us of the urgent need to cherish and protect our only home. As Voyager 1 continues its silent journey through the darkness beyond our solar system, it carries with it the legacy of human curiosity, ingenuity, and the unquenchable desire to explore. Its latest discovery in the depths of interstellar space hints at new cosmic mysteries waiting to be unveiled, perhaps even the momentous encounter with other life forms that so many have dreamed about. This odyssey, which began over 4 decades ago, continues to inspire and challenge us, inviting us all to look up, wonder, and reach ever further into the vast expanse of the universe. Voyager 1 was designed to push the boundaries of human knowledge, traversing vast distances where no spacecraft had dared to go before. Equipped with a suite of sophisticated scientific instruments, it was tasked with studying the giant planets and their moons, capturing unprecedented data that would forever change our understanding of the solar system. What makes Voyager 1 truly extraordinary is not just its groundbreaking discoveries, but its resilience and longevity. Despite being launched over 4 decades ago, it continues to send invaluable information back to Earth, maintaining a lifeline of communication through NASA's Deep Space Network. This unwavering connection allows scientists to receive data from more than 14 billion miles away, a testament to human ingenuity and determination. As Voyager 1 journeys beyond the heliosphere, the protective bubble created by the sun's solar wind, it enters interstellar space, a vast expanse filled with cosmic mysteries. Recently, a signal from Voyager 1 revealed the detection of an enigmatic object lurking in this farthest frontier. This revelation has sent shockwaves through the scientific community and reignited a question that has fascinated humanity for generations. Are we alone in the universe? The possibility that this mysterious detection could be evidence of advanced extraterrestrial life has captivated imaginations worldwide, inspiring scientists, philosophers, and dreamers alike to ponder the cosmic significance of this discovery. As we delve deeper into Voyager 1's findings, we are reminded of the boundless curiosity that drives human exploration, our relentless quest to understand not only the universe, but our place within it. In this unfolding cosmic saga, Voyager 1 stands as a symbol of hope, perseverance, and the unquenchable thirst for knowledge. Its voyage is not merely a scientific endeavor, but a profound journey that connects us all, uniting humanity in awe of the infinite cosmos that stretches beyond our wildest dreams. An intriguing aspect of the Voyager mission narrative lies in the remarkable timing. Voyager 1 began its epic journey just 16 days ahead of its cosmic twin, Voyager 2. This serendipitous alignment lends a sense of cosmic symmetry to an unparalleled saga. Two intrepid emissaries of humanity launched in close succession, each destined to explore the uncharted realms of our solar system and beyond. What truly distinguishes Voyager 1 from countless other space missions is its indomitable spirit of communication, a lifeline that it maintains steadfastly with Earth across unimaginable distances. This extraordinary feat is made possible by NASA's venerable Deep Space Network, a robust and sophisticated communication infrastructure designed to ensure a constant dialogue between the spacecraft and its home planet. This unyielding link serves a dual purpose. It allows Voyager 1 to receive precise commands from mission control and, in return, to transmit a treasure trove of invaluable scientific data back to its terrestrial origins. According to the most recent data, Voyager 1 currently finds itself at an astonishing distance of approximately 159.32 astronomical units (AU) from Earth. To put this monumental achievement into perspective, this distance translates to an awe-inspiring 23.834 billion kilometers, or roughly 14.8 billion miles, away from the cradle of humanity. In other words, Voyager 1 is now the most distant human-made object in existence, a lone traveler venturing farther into the cosmic ocean than any other craft before it. This staggering remoteness not only speaks to the spacecraft's incredible durability and the brilliance of human engineering, but also marks a milestone in our quest to understand the universe around us. It is this incomprehensible remoteness that firmly establishes Voyager 1 as the most distant human-made object ever to embark on an odyssey into the vast cosmos. From the moment of its launch, Voyager 1's primary mission objective was clear and profoundly ambitious: to explore and meticulously scrutinize the boundaries of the outer heliosphere, a mysterious and barely understood region known as the heliopause. This invisible boundary marks the outermost layer of the Sun's influence, the final frontier where the solar wind meets the vast interstellar medium, enveloping our entire solar system in a protective bubble. Through its relentless investigations, Voyager 1 has bestowed humanity with invaluable insights into the cosmos, especially within the confines of our immediate solar neighborhood. Propelled forward at an astonishing velocity of approximately 38,000 miles per hour, an incredible speed that allows it to traverse vast cosmic expanses day by day, the spacecraft continues to push the boundaries of exploration and knowledge. Yet, what truly sets Voyager 1 apart is not just its distance or speed, but its remarkable endurance. The spacecraft has not merely met expectations, it has far exceeded its originally projected lifespan. More than 4 decades after its historic launch, Voyager 1 remains operational, tirelessly sending back vital data from the farthest reaches of space. Its ongoing mission serves as a testament to human ingenuity, perseverance, and an insatiable desire to understand the universe around us. Voyager 1 has embarked on extraordinary decades of exploration, defying the limits of time and technology. Each passing day, this remarkable spacecraft dutifully records and transmits vital information about its celestial journey, offering humanity a continuous stream of priceless data from the edge of our solar system and beyond. Remarkably, Voyager 1 is expected to continue this awe-inspiring interstellar sojourn until at least the year 2025, a testament to its resilient propulsion systems and enduring power supply that have kept it operational far beyond initial expectations. By that time, it is estimated that Voyager 1 will have achieved an almost inconceivable distance of approximately 13.8 billion miles from the nurturing embrace of the Sun, a staggering measure of its pioneering voyage into the cosmic unknown. Accompanying Voyager 1 on this grand adventure is its celestial sibling, Voyager 2, both launched as part of NASA's legendary Voyager program. Together, they were equipped with a formidable array of 10 unique scientific instruments, each serving as sensory extensions of the spacecraft into the vast cosmos. This sophisticated ensemble of tools included television cameras, infrared and ultraviolet sensors, magnetometers, plasma detectors, cosmic ray and charged particle sensors, as well as state-of-the-art radio equipment, all meticulously designed to conduct groundbreaking experiments. These ingenious instruments have endowed Voyager 1 with the resilience and capability to withstand the harsh and unforgiving environs of deep space, allowing it to probe the unfathomable reaches of the unknown. One of the most indelible milestones in Voyager 1's storied journey was its close encounters with two of the most majestic and enigmatic bodies in our solar system, Jupiter and Saturn. These historic flybys provided humanity with an unprecedented window into the complexities and wonders of these gas giants, forever reshaping our understanding of the planetary giants and their moons. Voyager 1's encounters with the solar system's colossal planets, Jupiter and Saturn, were nothing short of historic. These celestial rendezvous, which occurred in 1979 and 1980, respectively, marked a watershed moment in the annals of scientific discovery. Through these close flybys, Voyager 1 gifted humanity with an unprecedented glimpse into the intricate complexities of these gas giants and their enigmatic retinues of moons. The spacecraft etched its name indelibly into history by uncovering previously unknown moons orbiting these planets, and by revealing the intricate and delicate ring structures that encircled both Jupiter and Saturn. Prior to Voyager 1's mission, much of this was speculation or incomplete knowledge. Its groundbreaking revelations not only captivated the scientific community, but also ignited the imaginations of people across the globe, heralding a new era of planetary exploration. One of Voyager 1's most iconic and enduring contributions to our cosmic understanding came in 1990 when the celebrated astronomer Carl Sagan championed a visionary concept. He urged the spacecraft to pivot its cameras and direct its lens back towards Earth. This simple yet profound act resulted in the creation of the now famous image known as the pale blue dot. The resulting image, now deeply etched into the collective consciousness of humanity, depicts Earth as a minuscule pale blue dot suspended in the vast cosmic ocean. This poignant image serves as a humbling reminder of the fragility and interconnectedness of our planet, underscoring the imperative to cherish and protect our world. A message that continues to resonate powerfully with people around the globe. Voyager 1's epic journey through the cosmos led it to encounter two of the most enigmatic and majestic celestial bodies in our solar system, Jupiter and Saturn. These monumental encounters provided a treasure trove of scientific data and imagery, fundamentally reshaping our understanding of these gas giants. Jupiter, the largest planet in our solar system, beckoned Voyager 1 with its beguiling mysteries. In March 1979, the spacecraft conducted a close flyby of this colossal giant, granting humanity its first intimate glimpse of the planet's immense scale and complexity. As Voyager 1 ventured closer, it unveiled a tapestry of astounding discoveries. One of the most captivating being the confirmation of Jupiter's intricate ring system. Before Voyager 1's arrival, these faint rings were only a hypothesis, but the spacecraft's keen instruments provided definitive evidence of their existence. Composed of fine, dark particles, these delicate rings encircle Jupiter in an ethereal fashion. The images captured by Voyager 1 offered an entrancing perspective on this subtle feature, captivating the world with their delicate beauty and adding a new dimension to our cosmic knowledge. Another remarkable revelation from Voyager 1's encounter with Jupiter was the unveiling of intricate weather patterns and tempestuous storms on the gas giant's surface. Among these tempests, the most iconic was the Great Red Spot, a colossal storm that has raged for centuries. Voyager 1's imagery of this mammoth tempest not only illuminated the storm's complex structure and dynamic behavior, but also ignited the public's fascination with Jupiter's tumultuous atmosphere. Furthermore, Voyager 1's instruments detected Jupiter's powerful magnetosphere, a colossal magnetic field that dwarfs Earth's own magnetic envelope. This groundbreaking discovery provided crucial insights into the planet's magnetic dynamo and shed light on how this immense magnetic field interacts with its retinue of moons, influencing their environments and contributing to the complex space weather around Jupiter. Following its momentous encounter with Jupiter, Voyager 1 continued its epic odyssey towards Saturn, the majestic ringed planet. In November 1980, the spacecraft made its closest approach to this cosmic wonder, offering humanity an intimate view of Saturn's stunning rings and captivating moons. The detailed images and data collected unveiled previously unseen features of the ring's delicate structure and composition, as well as the diverse geology and atmospheres of Saturn's many moons. One of Voyager 1's most iconic contributions to human perspective came in 1990 with the celebrated pale blue dot image. The esteemed astronomer Carl Sagan championed a visionary idea. He implored the spacecraft to pivot its cameras and turn its lens back toward Earth. This image immortalized our planet as a tiny, fragile speck suspended in the vastness of space, inspiring reflection on our place in the cosmos and a renewed commitment to safeguarding our shared home. The resulting image, now etched deeply into the collective consciousness of humanity, depicts Earth as a minuscule pale blue dot suspended in the vast cosmic ocean. This poignant and humbling image serves as a powerful reminder of the fragility, vulnerability, and profound interconnectedness of our planet within the boundless expanse of the universe. It underscores the urgent imperative to cherish, protect, and preserve our delicate home, a message that continues to resonate with people from all corners of the globe, inspiring reflection on our shared responsibility to safeguard life on Earth. While Voyager 1's extraordinary odyssey primarily focused on the majestic gas giants Jupiter and Saturn, its twin spacecraft, Voyager 2, embarked on a distinct and equally remarkable trajectory. Voyager 2 was destined to explore the enigmatic ice giants of our solar system, Uranus and Neptune, planets shrouded in mystery and complexity, presenting a fresh array of cosmic enigmas for scientists and humanity to unravel. Uranus, the seventh planet from the Sun, is a celestial enigma for many reasons, not least of which is its extraordinary rotation. Unlike any other planet in our solar system, Uranus rotates on its side, with an axial tilt of approximately 98 degrees. This unusual orientation is believed to be the aftermath of a colossal and cataclysmic collision with a massive celestial object in the distant past, which drastically altered the planet's spin. This tilt results in extreme seasonal variations lasting over decades, offering a unique glimpse into planetary dynamics that differ greatly from those of Earth and its planetary neighbors. Despite its unusual tilt and mysterious origins, Uranus remains a captivating and fascinating world. It is approximately 4 times the diameter of Earth and boasts a cold, icy atmosphere composed mainly of hydrogen, helium, and methane, giving it a characteristic blue-green hue. Voyager 2's historic flyby of Uranus in January 1986 marked a momentous milestone in space exploration. For the first time, humanity received detailed images and comprehensive scientific data of this distant ice giant, expanding our knowledge far beyond previous telescopic observations. Among the many groundbreaking discoveries during Voyager 2's encounter was the revelation that Uranus possesses a complex system of rings, a surprising finding since rings were once thought to be unique to Saturn. Voyager 2 revealed that these rings consist of dark, narrow bands composed of tiny particles and debris orbiting the planet, hinting at dynamic processes within Uranus's gravitational influence. In addition to its rings, Voyager 2 discovered 10 new moons orbiting Uranus, each with its own unique characteristics and geological histories. The spacecraft's instruments also provided valuable insights into the planet's atmosphere, uncovering high-speed winds and unexpected temperature variations that challenged existing models of planetary atmospheres. These findings offered a new window into the workings of ice giants, enriching our understanding of planetary formation and behavior in the outer solar system. Voyager 2's journey did not end with Uranus. It continued onward to Neptune, the outermost planet in our solar system, arriving in August 1989. Neptune, with its striking deep blue color and fierce weather systems, presented yet another frontier of exploration and discovery. The data and images sent back by Voyager 2 from Neptune's vicinity revealed powerful storms, supersonic winds, and a moon with active geysers. An astounding discovery that further deepened our appreciation for the dynamic complexity of these distant worlds. Together, the twin Voyager spacecraft have revolutionized our understanding of the solar system's outer realms. Their pioneering missions, spanning more than 4 decades, have transformed once faint and distant dots in the night sky into vividly detailed worlds, full of mystery and wonder. These missions continue to inspire generations of scientists, dreamers, and explorers, reminding us that even at the very edges of human reach, the universe holds countless secrets waiting to be discovered. Voyager 2 revealed a diverse and captivating retinue of moons orbiting Uranus, each possessing unique geological and atmospheric features. Among these, moons like Miranda, Ariel, and Titania stood out, showcasing dramatic landscapes marked by massive canyons, unusual fault lines, and evidence of past geologic activity. These discoveries significantly enriched humanity's understanding of Uranus, shedding light on the complex interactions between the planet and its satellites, and deepening the intrigue surrounding this enigmatic, sideways rotating giant. Voyager 2's interstellar voyage did not end at Uranus. It pressed onward, journeying even farther to reach Neptune, the eighth and most distant known planet from the Sun. Neptune, with its frigid temperatures and vibrant azure hue, remains a haunting symbol of the solar system's outer frontier. This distinct blue coloration is due to the high concentration of methane in its atmosphere, which absorbs red light and reflects the blue. In August 1989, Voyager 2 conducted a historic flyby of Neptune, marking the first, and so far only, close encounter with this distant world. The images and data transmitted back to Earth during this flyby were nothing short of revolutionary. Voyager 2 unveiled a planet with a surprisingly dynamic atmosphere, teeming with violent storms and fierce winds, the fastest sustained winds recorded in the solar system, reaching speeds of over 2,000 kilometers per hour, about 1,200 miles per hour. Among Neptune's most notable atmospheric features was the discovery of the Great Dark Spot, a colossal storm system reminiscent of Jupiter's famous Great Red Spot. However, unlike its Jovian counterpart, the Great Dark Spot proved to be ephemeral. It mysteriously vanished in later observations, raising questions about the atmospheric dynamics of Neptune and the transient nature of its weather system. Perhaps one of the most astonishing revelations from Voyager 2's Neptune encounter was the discovery of the planet's largest moon, Triton, to be an exceptional celestial body that defied expectations. Triton orbits Neptune in a retrograde direction, meaning it moves in the opposite direction of Neptune's rotation. A rare trait that strongly suggests Triton is a captured object, possibly a former Kuiper Belt object that was gravitationally ensnared by Neptune in the distant past. Triton's surface was revealed to be a frozen yet geologically active world, exhibiting nitrogen geysers erupting from beneath its icy crust, a phenomenon never before observed on a celestial body so distant from the Sun. This cryovolcanic activity indicated that Triton, despite its remoteness and frigid temperatures, harbors internal heat and dynamic processes beneath its surface. Voyager 2's images showed a landscape marked by frozen plains, ridges, and sparsely cratered terrain, suggesting a young and possibly evolving surface. These groundbreaking discoveries at Neptune and Triton not only captivated the global scientific community, but also sparked the imaginations of people around the world. The Voyager 2 mission demonstrated the boundless potential of human curiosity and ingenuity, reminding us that even the most remote and mysterious corners of our solar system can be brought into the realm of human understanding. Voyager 2's historic flybys of Uranus and Neptune marked the end of humanity's first grand tour of the outer planets. A monumental chapter in the annals of space exploration, yet, like its twin Voyager 1, Voyager 2 continues to voyage beyond the known, transmitting faint whispers of data from the edge of interstellar space, ensuring that its legacy endures not just in scientific discovery, but in the shared human spirit of exploration. Triton, the largest moon of Neptune, emerged as one of the most fascinating and enigmatic celestial bodies encountered during Voyager 2's interplanetary odyssey. The spacecraft's imagery revealed a world brimming with activity, despite its remote location and frigid climate. Among Triton's most extraordinary features were geysers that erupted from beneath its icy surface, spewing nitrogen gas high into the moon's thin atmosphere. These geysers created vast plumes that extended kilometers above the surface, where the nitrogen would condense into snow-like particles and gently settle back to the ground, sculpting a surreal and alien landscape of frost and ice. This striking phenomenon was unlike anything previously observed in the solar system, offering profound insights into cryovolcanism, the eruption of volatile substances like water, ammonia or methane, rather than molten rock. Triton's surface, relatively young and sparsely cratered, hinted at a geologically active history, defying expectations for a moon so far from the sun. Perhaps even more puzzling was Triton's retrograde orbit. It revolves around Neptune in the direction opposite to the planet's rotation. This uncommon trait strongly suggests that Triton did not form alongside Neptune, but was instead a captured object, likely originating from the Kuiper Belt. Its gravitational capture would have disrupted Neptune's original satellite system and left Triton locked in a stable but unusual orbital dance, one that continues to intrigue astronomers to this day. Voyager 2's encounters with Uranus and Neptune remain unparalleled achievements in the history of space exploration. To this day, no other spacecraft has visited these distant ice giants, making Voyager 2's observations and data collection an irreplaceable scientific treasure. The trove of information gathered during these historic flybys continues to fuel research and hypotheses, offering glimpses into the atmospheric dynamics, magnetic fields, ring systems, and unique satellite compositions of these mysterious worlds. While Voyager 2 was delving into the secrets of the outer planets, its twin, Voyager 1, was forging an even more audacious path, a journey that would take it beyond the boundaries of the solar system and into interstellar space. This transition, which occurred in August 2012, marked a profound and historic milestone for humanity. For the first time, a human-made object had crossed the heliopause, the boundary where the solar wind yields to the interstellar medium. Voyager 1's entry into interstellar space did not signify the end of its mission, but rather the beginning of a new chapter. As it continues its voyage through the vast and silent reaches of the cosmos, it carries with it not only scientific instruments, but also a symbolic message from Earth, etched in the form of the Golden Record, a phonograph disc containing sounds, music, and greetings from our planet. Now billions of miles from Earth, Voyager 1 operates in a realm beyond the Sun's influence, where the environment is dominated by particles, fields, and forces that originate from other stars. Its instruments, though fewer in number now, continue to return invaluable data about the nature of interstellar space, helping scientists to understand the shape and boundary of the heliosphere and the conditions in the space between the stars. The enduring journey of the Voyager spacecraft, Voyager 1, venturing outward into the galaxy, and Voyager 2, providing the only close-up views of Uranus and Neptune, remains one of the most ambitious and successful missions in the history of space science. They have not only expanded the boundaries of human knowledge, but have also inspired generations to look upward and dream of what lies beyond, gathered groundbreaking data that challenged earlier assumptions and reshaped our understanding of this mysterious frontier. Rather than a simple comet-like structure with a long tail trailing away from the Sun, Voyager 1's measurements suggested that the heliopause is more complex, possibly a distorted bubble-like shape influenced by both the solar wind from within and interstellar forces from beyond. As Voyager 1 crossed this boundary in 2012, it recorded a sudden and lasting drop in solar particles, while simultaneously detecting a surge in galactic cosmic rays, energetic particles that originate from supernovae and other powerful cosmic phenomena far outside our solar system. This was the smoking gun, clear empirical evidence that the spacecraft had exited the heliosphere and entered the vast ocean of interstellar space. Within this realm, Voyager 1's instruments continued to function, albeit in a limited capacity due to the fading power supply and increasing distance. Even so, its plasma wave subsystem detected a persistent background hum, long, low-frequency vibrations in the plasma of interstellar space. This discovery provided an unprecedented glimpse into the density and behavior of particles between the stars, and demonstrated that the void of space is, in fact, filled with subtle and dynamic forces. Voyager 1's ongoing mission in interstellar space is a testament to both technological resilience and scientific ambition. It represents the first time humans have been able to directly measure the environment of interstellar space, rather than relying solely on telescopes or theoretical models. The data sent back by Voyager 1 continues to challenge assumptions and refine our models of how the Sun interacts with the galaxy around it. As it sails farther into the unknown, Voyager 1 is also pushing the limits of communication, its faint signals traveling at the speed of light now take over 22 hours to reach Earth. Each byte of data is a time capsule, whispering stories from the edge of the solar system to a waiting world. Despite being over 46 years old, the spacecraft continues to surprise. In recent years, engineers have performed innovative workarounds to keep it operational, including rerouting functions through backup systems. These efforts ensure that even in its twilight years, Voyager 1 remains a pioneer, a silent emissary of Earth, drifting among the stars. Its journey into interstellar space is not just a scientific achievement, but a symbolic one. Voyager 1 carries the golden record, a carefully curated message intended for any intelligent life that might one day encounter it. Engraved with greetings in 55 languages, music from cultures across the Earth, and images depicting life on our planet, the golden record serves as humanity's cosmic calling card, a whisper to the universe saying, "We were here, we reached this far, and we are curious." Voyager 1 is now far beyond the planets, beyond the influence of our star, continuing its voyage in the silence of deep space. It is alone, yet never forgotten. His legacy etched into history, its mission ongoing, and its story inspiring countless new explorers to reach for the stars. These observations from Voyager 1 provided a transformative understanding of the heliopause and its complex relationship with the galactic environment. Prior to Voyager's journey, much of what scientists knew about the heliosphere was theoretical, based on models, simulations, and indirect evidence. But as Voyager 1 approached and eventually crossed the heliopause, it delivered empirical measurements that revolutionized the field. One of the most unexpected discoveries was the behavior of the magnetic field at the boundary. Scientists had expected a sharp shift in the direction of the magnetic field lines as Voyager 1 transitioned from the Sun's influence to the interstellar medium. However, what they observed was a subtle and unexpected continuity. The magnetic field beyond the heliopods remained aligned in a way that puzzled researchers. This anomaly suggested that the heliosphere might not be as sharply defined or as neatly contained as once imagined. Instead, it could be intertwined or blended with interstellar forces in ways that challenge our understanding of the boundary between solar and galactic domains. These deviations hinted at previously unknown interactions between the solar wind and the interstellar magnetic field, painting a far more dynamic and fluid picture of the Sun's outermost frontier. In addition to its findings on magnetic fields, Voyager 1 also measured plasma density in interstellar space. Unlike within the solar system, where plasma is sparse and influenced by solar activity, the interstellar medium was found to be denser, yet cooler and more stable. This provided critical data that helped astronomers refine their understanding of the material that fills the vast regions between star systems. Voyager 1's traversal into and beyond the heliopause did more than just expand the scientific boundaries of astrophysics. It redefined the scale of our solar system. What was once thought to end at the orbit of Pluto, or perhaps Neptune, was now clearly shown to extend tens of billions of kilometers farther. Enveloped in a vast and shifting magnetic bubble, these findings are not merely academic. They have profound implications for future missions and our long-term aspirations for space travel. Understanding the heliosphere's structure is essential for developing technologies that could one day protect human explorers from cosmic radiation as we venture further from Earth. It also helps in mapping the interstellar environment that any spacecraft, robotic or crewed, would encounter as it journeys to the stars. In essence, Voyager 1's study of the heliosphere turned a once theoretical concept into a tangible and measurable structure, revealing it as a living, breathing force field that protects and defines the domain of our Sun. And while many questions remain about its shape, its interaction with the galaxy, and how it evolves over time, Voyager 1 laid the first real footprints on this invisible frontier. It's a testament to human curiosity and engineering that a spacecraft launched in 1977 continues to inform us decades later about regions of space we had never directly touched before. The mission of Voyager 1 not only broadened our understanding of the heliosphere, but also reminded us that exploration, no matter how distant or difficult, brings us closer to the truth of our place in the cosmos. These contrasting environments encountered by Voyager 1 and Voyager 2 as they crossed the heliopause added profound depth to our understanding of interstellar space. Although both spacecraft pierced the boundary that separates the Sun's protective bubble from the galaxy beyond, the variations in local space weather, magnetic field intensity, and particle density between their paths suggested that interstellar space is not uniform. It is a complex and evolving landscape, shaped by both local and galactic forces. Voyager 2's instruments, still fully operational at the time of its heliopause crossing, recorded direct plasma measurements, something Voyager 1 could not do initially due to a malfunction in its plasma instrument. This allowed Voyager 2 to directly confirm the dramatic rise in plasma density beyond the heliopause, complementing the data Voyager 1 had previously inferred using its cosmic ray and magnetic sensors. This corroboration between two different observational methods provided compelling evidence for a denser interstellar medium just outside our solar system. Moreover, the turbulence Voyager 2 encountered, manifested as fluctuating magnetic fields and wave-like plasma interactions, indicated a more chaotic boundary layer. Scientists hypothesize that this may be due to differences in solar wind pressure or local interstellar cloud structures that distort the heliosphere's edge. In contrast, Voyager 1's path appeared to be through a calmer, more sensitive this frontier is to cosmic condition. Together, these findings from both spacecraft are enabling scientists to create the first three-dimensional models of the heliosphere's outer boundary, which help illustrate its shape, behavior, and interaction with the galaxy. These models are crucial not only for understanding our own solar environment, but also for contextualizing the protective magnetic bubbles that might surround other stars, possibly shielding exoplanets from harmful radiation and influencing their potential to host life. In essence, Voyager 1 and Voyager 2, though launched within weeks of each other, have become dual ambassadors to the galaxy, each offering a distinctive lens on the final frontier of our solar system. Their separate experiences highlight that the edge of our solar system is not a fixed wall, but a living, breathing boundary, shaped by the solar wind's strength, the interstellar medium's density, and galactic magnetic fields that we are only beginning to understand. As Voyager 2 continues its journey through this turbulent interstellar zone, it adds more layers to the grand narrative begun by its twin. Together, they are charting a realm never before visited by humankind. And in doing so, they remind us that even at the edges of our influence, human curiosity and ingenuity still thrive. Reaching out into the unknown, guided by the faint whispers of data traveling billions of kilometers back to Earth, journey marks both a triumph of engineering and a poignant reminder of the finite nature of even our most enduring creations. Now well over 46 years since its launch, Voyager 1 continues to drift deeper into the uncharted sea of interstellar space, carrying with it the legacy of Earth's first true attempt to reach beyond the confines of the Sun's domain. Yet, as the spacecraft travels ever farther, it faces increasing challenges. Its power supply, generated by radioisotope thermoelectric generators, RTGs, is gradually weakening. As of now, NASA engineers have been shutting down non-essential systems to conserve energy and extend the mission's lifespan. Sometime in the late 2020s or early 2030s, Voyager 1 will likely go silent, as its power becomes insufficient to sustain even the low-energy communications that still reach Earth today. Despite this inevitable silence, the spacecraft will not stop traveling. Long after it can no longer send signals or power its instruments, Voyager 1 will continue coasting through the Milky Way galaxy, a silent sentinel bearing the golden record, waiting for a distant intelligence, if such an intelligence exists, to encounter it. This golden record, painstakingly curated by a team led by Carl Sagan, includes greetings in 55 languages, music from a wide range of cultures and eras, from Bach and Beethoven to traditional songs from Japan, Senegal, and Peru. Images depicting life on Earth, human anatomy, architecture, DNA structures, and the planet's ecosystems. Sounds of Earth, including the laughter of a child, the roar of the ocean, thunder, and the chirping of birds. These records serve as a kind of cosmic message in a bottle, not with the hope of rescue, but as a declaration: we were here. We reached for the stars. We tried to understand the universe and ourselves. In this way, Voyager 1 and Voyager 2 have transcended their original scientific missions. They have become monuments of human creativity and persistence, testaments to a civilization that dared to send its voice into the dark with no guarantee of reply. They represent an act of faith in the future, a belief that knowledge, wonder, and the desire to explore are enduring parts of what it means to be human. As we gaze toward the heavens, tracking the faint signals from these emissaries, we are reminded that our reach has already extended beyond the solar system, and that even in the cold emptiness of space, our story continues. the Voyager mission teaches us that the journey itself, filled with discovery, wonder, and enduring hope, is as important as the destination. Voyager 1's incredible journey has reignited the world's fascination with this fearless spacecraft after more than 4 decades of exploration. Voyager 1 has traveled far beyond our solar system, venturing deep into interstellar space. It has crossed the heliopause, the boundary where the sun's influence fades, and now drifts through a vast, uncharted region of the galaxy. In August 2022, Voyager 1 sent a mysterious message back to Earth, one that captured the imagination of scientists and space fans everywhere. Amid streams of data and telemetry, researchers detected a strange anomaly, an object of unknown origin and makeup. Tentatively named the Cosmic Enigma, this object is unlike anything ever encountered in the history of space exploration. What makes the Cosmic Enigma so puzzling? It emits faint, irregular signals that don't match any known natural celestial phenomena. Even more intriguing, its path through space seems deliberate, as if it's following a specific course through the cosmos. This discovery raises deep and fascinating questions. Where did this object come from? Who or what created it? And what might its intentions be? Scientists and astronomers around the world have been meticulously analyzing the data sent by Voyager 1, determined to unlock the secrets of the mysterious cosmic enigma. Could this baffling object be a remnant of an advanced extraterrestrial civilization, or perhaps a probe launched from a distant corner of the galaxy? Alternatively, might it be an entirely new and unknown cosmic phenomenon? The discovery has ignited a wave of speculation and debate, bringing together experts from diverse fields who are collaborating to unravel the enigma's true nature. One leading theory suggests that the cosmic enigma could be an ancient relic from a long-lost civilization, a probe dispatched eons ago, its original mission veiled in the mists of time. Whether its purpose was scientific, exploratory, or something beyond our imagination remains an intriguing mystery. On the other hand, some scientists propose that this object might be a natural celestial phenomenon, with properties that challenge our current understanding of astrophysics. This possibility reminds us of the universe's immense complexity and the vast diversity of cosmic phenomena still waiting to be discovered. It highlights how much we have yet to learn and how little of the universe's secrets we have uncovered. The detection of the cosmic enigma underscores the critical importance of continued space exploration. It calls for humanity to push further into the cosmos, to embrace the unknown, and to expand our cosmic reach. The universe is a vast, mysterious frontier, filled with wonders and enigmas that inspire awe and curiosity. As Voyager 1 continues its solitary voyage through interstellar space, carrying with it the mystery of the cosmic enigma, humanity stands on the brink of new discovery. This spacecraft has become Earth's ambassador to the stars, a shining symbol of our insatiable curiosity and unyielding desire to explore. Voyager 1's odyssey, spanning over 4 decades, has fundamentally reshaped our understanding of the universe. It continues to inspire generations of scientists, dreamers, and stargazers alike. As we ponder the mysteries of the cosmic enigma and the endless possibilities it represents, we are reminded that the cosmos is a vast, wondrous, and ever-evolving realm. Each new discovery brings us closer to answering one of humanity's most profound questions. Are we alone in the universe? With its indomitable spirit and enduring mission, Voyager 1 carries our hopes and dreams as it forges onward into the cosmic unknown. The story of Voyager 1 is a testament to the enduring human spirit of exploration, curiosity, and the relentless quest for knowledge. It transcends time and space, reminding us of our place in the universe and the boundless wonders awaiting us in the cosmic expanse. The enigma of the cosmic enigma serves as a poignant reminder that the universe is filled with mysteries yet to be unraveled. It invites us to continue our cosmic journey with wonder and humility, ever eager to explore the depths of the unknown. Voyager 1, humanity's cosmic emissary, continues to inspire us to reach for the stars and embrace the infinite possibilities that lie beyond. We choose to go to the moon not because it is easy, but because it is hard. Because the greatest achievements in human history have always come from tackling the toughest challenges. This decade, humanity is preparing to return to the moon, aiming for the mysterious and uncharted lunar South Pole. As we move farther from the equator here on Earth, the sun's path in the sky dips lower, casting long shadows and colder nights. On the moon, the effect is even more extreme. Near its south pole lie craters with towering rims, so deep and dark that sunlight never reaches their floors. These permanently shadowed regions are some of the coldest places in the solar system and may hold valuable reserves of ice, frozen water that could be vital reserves for future explorers. Exploring these shadowed craters is more than a scientific quest. It's a symbol of our relentless spirit of discovery. It is a mission driven by curiosity, courage, and the unyielding desire to push beyond the known. As we prepare to step back onto the moon, we embrace not only the challenge, but the endless possibilities that come with it. The chance to learn, to grow, and to take another giant leap for humanity. When asteroids and comets collide with the moon, they bring something extraordinary with them: water. Comets, in particular, are known to contain significant amounts of water ice. When this water lands in certain areas on the moon, called cold traps, it doesn't evaporate or disappear. It's trapped in these permanently shadowed craters where sunlight never reaches. These cold traps act like natural reservoirs, preserving water ice for millions of years. This discovery is incredibly important because water is one of the most valuable resources for any space mission. Not only is it essential for drinking and sustaining life, but it also holds the potential to revolutionize how we explore space. Here's the fascinating part. Water on the moon can actually be converted into rocket fuel. Water is made up of two elements, hydrogen and oxygen, combined as H2O. Scientists have developed ways to split water molecules through a process called electrolysis, separating hydrogen and oxygen gases. These gases can then be stored and later recombined in rocket engines to create powerful thrust. When hydrogen burns in oxygen, it produces water vapor as exhaust, making it one of the cleanest fuels imaginable. This means that instead of carrying all the fuel needed for a mission from Earth, future astronauts could produce rocket fuel right on the moon using local water resources. This breakthrough could drastically reduce the cost and complexity of deep space exploration. The idea of using lunar water as fuel is a game changer. It transforms the moon from just a distant destination into a vital refueling station for missions traveling farther into the solar system, whether to Mars, the asteroids, or beyond. This incredible potential turns the moon into more than just a stepping stone. It becomes a launching pad for humanity's next great adventures in space. And it all starts with something as simple and essential as water. one of life's most basic ingredients, now poised to fuel our journey to the stars. Rocket fuel made from hydrogen and oxygen isn't just science fiction. It's the very engine behind some of humanity's greatest space achievements. The massive orange external tank you see on the space shuttle was filled with liquid hydrogen and liquid oxygen. When these two elements combine in the main engines, they create the tremendous thrust needed to launch the shuttle into orbit. It's powerful, efficient, and produces only water vapor as exhaust, a clean fuel source that helped humanity reach new heights. Speaking of historic achievements, the Apollo program, initiated by NASA in the 1960s, remains one of the most iconic chapters in human space exploration. While Apollo 11 famously marked the first human footsteps on the moon, the story didn't end there. The missions that followed continued to uncover the moon's secrets and broaden our scientific understanding of our celestial neighbor. Take Apollo 12, the second mission to successfully land on the lunar surface. This mission had a special target, Surveyor 3, an unmanned spacecraft that had touched down on the moon in 1967. Astronauts Charles Peet, Conrad and Alan L. Bean conducted 2 moonwalks, during which they collected valuable lunar rock and soil samples. They also performed experiments that helped scientists understand the properties of the lunar surface, known as the regolith. Apollo 12's findings provided critical insights into how the moon's environment affects materials over time. This knowledge is essential as we plan future missions and the possibility of long-term lunar bases. Each step taken by the Apollo astronauts has paved the way for today's exploration efforts, fueling our desire to return and learn more. Apollo 14, led by Commander Alan B. Shepard Jr. is famously remembered not just for its scientific achievements, but for a playful moment in space history. Shepard attached a makeshift golf club to a lunar sample scoop handle and took a swing on the moon's surface, sending a golf ball rolling in low gravity. This whimsical act masked the serious scientific work underway, which included collecting a wide range of lunar samples, conducting seismic experiments, and deploying various scientific instruments. Apollo 15 marked a new era of lunar exploration with the introduction of the Lunar Roving Vehicle, LRV. Astronauts David R. Scott and James B. Irwin used this rover to travel farther and collect a diverse array of geological samples. One of their key discoveries was a green mineral called olivine, offering strong evidence of the moon's volcanic past. Scott and Irwin also famously performed the hammer and feather experiment, confirming Galileo's theory that objects of different masses fall at the same rate when air resistance is absent. A perfect demonstration in the moon's airless environment. Apollo 16, commanded by John W. Young, with lunar module pilot Charles M. Duke, focused its exploration on the Descartes Highlands, an area known for unique geological features. They spent a record-breaking 71 hours traversing the lunar surface, collecting over 200 pounds of lunar samples. Their work provided valuable insights into the moon's history and formation, enriching our understanding of our closest celestial neighbor. The final Apollo lunar landing, Apollo 17, featured the first professional geologist astronaut, Harrison H. Schmitt, alongside Commander Eugene A. Cernan. Together they explored the Taurus-Littrow Valley, uncovering fascinating discoveries such as the orange soil, an unusual volcanic deposit that shed new light on the moon's volcanic activity and geological evolution. These Apollo missions not only expanded humanity's knowledge of the moon, but also laid the groundwork for future exploration, inspiring generations to look up at the stars and dream bigger than ever before. As the last person to leave the lunar surface, Commander Eugene A. Cernan etched his daughter's initials into the lunar regolith, a deeply personal and poignant gesture marking the close of the Apollo era. This simple act symbolized the human connection to the moon and the lasting legacy of those historic missions. Beyond their monumental place in history, the Apollo missions provided an immense wealth of scientific data that continues to shape our understanding of the moon and the broader solar system. The lunar samples brought back to Earth have been meticulously studied, revealing that the moon is approximately 4.5 billion years old, almost as ancient as our own planet. One of the most groundbreaking discoveries was the presence of water in the form of hydroxyl molecules within the lunar soil and rocks. This finding opened new possibilities, suggesting that water could potentially be extracted directly from the moon's regolith. Access to lunar water is a game-changer for future missions, providing a vital resource for human settlement and long-term exploration. In addition, the study of lunar rocks and soil has offered invaluable insights into the moon's volcanic history and geological evolution, helping scientists piece together its complex past. These discoveries continue to inform and inspire today's efforts to return to the moon and to go even further into the cosmos. The Apollo missions not only marked an extraordinary chapter in human history, but also transformed our understanding of the moon's geology. Through their explorations, astronauts uncovered compelling evidence of ancient volcanic activity, including vast lava flows that once reshaped the lunar surface. These volcanic processes contributed to the formation of enormous basins, some spanning hundreds of kilometers, that have shaped the moon's distinctive landscape. Such geological features offer critical clues about the moon's past and provide a window into the early history of our solar system. Moreover, the Apollo missions carried out highly precise measurements of the moon's gravitational field. This data revealed valuable information about the moon's internal structure, showing how its dense core, mantle, and crust interact. Understanding the moon's gravitational variations has helped scientists develop models for how not only the moon but also other celestial bodies evolve and change over billions of years. These insights extend beyond lunar science. They enrich our knowledge of planetary formation and dynamics throughout the solar system. As we move into the 21st century, lunar exploration has experienced a remarkable resurgence. Driven by technological advances and renewed global interest, space agencies worldwide are once again setting their sights on the moon. Recognizing its importance as both a scientific treasure trove and a strategic platform for deeper space exploration, India has emerged as a key player in this modern lunar renaissance. Its Chandrayaan program has made significant strides in advancing our understanding of the moon. Chandrayaan-1, launched in 2008, was India's first lunar probe and delivered groundbreaking discoveries, including the first confirmed evidence of water molecules on the lunar surface. Building on this success, Chandrayaan-2, launched in 2019, further advanced India's lunar ambitions with an orbiter, lander, and rover designed to conduct detailed surface studies, although the lander experienced a hard landing. Despite this setback, the orbiter continues to send valuable scientific data, highlighting the resilience and determination behind the mission. Chandrayaan-3, launched in 2023, represents India's unwavering commitment to lunar exploration and scientific discovery. This mission specifically targeted the Moon's south pole, a region of immense interest to scientists and explorers alike. The South Pole is unique because it contains permanently shadowed craters, areas where sunlight never reaches. These cold traps are believed to harbor significant amounts of water ice, which is crucial for sustaining future human presence on the Moon. Water ice can be used not only for drinking and life support, but also as a raw material to produce oxygen and hydrogen fuel, enabling longer missions and potentially fueling voyages deeper into the solar system. In addition to water ice, the South Pole geological diversity offers opportunities to study the Moon's history and the broader processes that have shaped planetary bodies over time. The extreme lighting conditions and rugged terrain make this region challenging to explore, but also incredibly rewarding in terms of the scientific knowledge it can yield. India's Chandrayaan-3 mission showcases the international trend of renewed lunar exploration, where scientific goals are tightly linked with long-term plans for sustainable human activity beyond Earth. Other nations, such as China, the United States, Russia, and the European Space Agency, are similarly advancing ambitious missions to the Moon, aiming to establish research bases, conduct resource extraction, and prepare for future manned missions to Mars and beyond. This new era of lunar exploration not only honors the legacy of the Apollo program, but also pushes humanity toward a future where the Moon serves as a springboard for space exploration, scientific discovery, and even commercial ventures. As we continue to unlock the Moon's secrets, each mission brings us closer to understanding our place in the universe and prepares us for the challenges and opportunities that lie ahead. The craters in the Moon's South Pole region are believed to contain deposits of water ice, a resource of immense value for future lunar exploration and the potential establishment of permanent lunar bases. Water ice can support life, provide drinking water, and even be broken down into hydrogen and oxygen for rocket fuel, making it a cornerstone for sustainable human presence beyond Earth. Chandrayaan-3 was specifically designed to investigate these shadowed craters, analyze the lunar soil, and conduct scientific experiments to unravel the Moon's geological history. The mission comprised two main modules: Vikram II, the lander, and Pragyan-2, the rover. Vikram II's successful soft landing on the lunar surface was a historic milestone, positioning India among the select group of nations capable of achieving this complex feat with precision and reliability. Pragyan-2, equipped with advanced scientific instruments, then began its journey across the lunar terrain. As it roamed, Pragyan-2 carried out a series of experiments designed to analyze the soil's composition, study the Moon's mineralogy, and detect signs of water ice. The rover transmitted a wealth of valuable data back to Earth, significantly expanding our understanding of the Moon's South Pole region. One of the mission's most groundbreaking discoveries was the confirmation of water ice within the permanently shadowed craters. This finding holds profound implications for the future of lunar missions, as it offers a sustainable source of water and fuel right on the Moon itself. The presence of water ice means that astronauts on future missions may not need to rely solely on supplies from Earth, drastically reducing the cost and complexity of lunar exploration. The Chandrayaan-3 mission has thus not only advanced scientific knowledge, but also paved the way for humanity's long-term presence on the Moon. As we continue to explore and understand our closest celestial neighbor, missions like Chandrayaan-3 provide the critical data and inspiration needed to push the boundaries of space exploration further than ever before. The story of lunar exploration, from the pioneering Apollo missions to the groundbreaking Chandrayaan-3, carries profound implications for humanity's understanding of the cosmos and our place within it. The moon is much more than a distant celestial body. It serves as a vital stepping stone for the next great leaps in space exploration, including ambitious missions to Mars and beyond. One of the moon's most important roles is as a natural laboratory and testing ground for technologies that will be critical for long-duration space travel. Its proximity to Earth, just about 384,400 kilometers away, makes it accessible enough to allow relatively frequent missions and rapid communication. Moreover, the moon's low gravity, roughly 1/6 that of Earth, presents a unique environment where engineers and scientists can develop and refine life support systems, habitat construction methods, and other technologies essential for sustained human presence beyond our planet. The potential resources found on the moon, such as water ice hidden in its permanently shadowed craters, hold the promise of enabling self-sufficient exploration. These resources could provide astronauts with drinking water, breathable oxygen, and even fuel, dramatically reducing the need to carry everything from Earth. This capability is critical for establishing a permanent lunar base and for making Mars missions feasible, turning the moon into a gateway to the rest of the solar system. Beyond its scientific and practical value, the moon holds a deep historical and cultural significance that transcends its role in space exploration. For millennia, the moon has been a source of fascination, inspiration, and wonder for poets, artists, philosophers, and dreamers across civilizations. It has been woven into myths, stories, and art that express humanity's enduring curiosity and yearning to understand the universe. The Apollo missions brought the moon into the global spotlight in an unprecedented way. The iconic images of Earth rising above the lunar horizon, captured during these missions, revolutionized our perspective of our home planet. For many, seeing Earth as a fragile, beautiful blue marble suspended in the vastness of space fostered a newfound sense of global interconnectedness and environmental stewardship. It reminded us that despite our differences and borders, we all share one planet and one fragile ecosystem. Today, missions like Chandrayaan-3 continue this legacy, deepening our scientific understanding while reigniting the spirit of exploration. Each step forward on the lunar surface is a reminder of humanity's boundless curiosity and our innate desire to push the frontiers of knowledge. The moon's enduring presence in human history and its pivotal role in the future of space travel embody the dual essence of exploration, both a journey outward into the cosmos and inward into the shared dreams and aspirations of humankind. In this way, the moon stands as a symbol of hope, unity, and the endless possibilities that arise when we dare to explore the unknown. As we look forward to new missions, new discoveries, and perhaps even human settlements on the lunar surface, we are reminded that the quest to understand the moon is ultimately a quest to understand ourselves and our place in the vast, mysterious universe. Moreover, the exploration of the moon stands as a remarkable testament to human ingenuity, collaboration, and the relentless pursuit of knowledge. It embodies the extraordinary achievements that are possible when nations, scientists, engineers, and visionaries from around the world come together, united by a shared spirit of discovery and the drive to push beyond the boundaries of the known. The moon has become a symbol of what humanity can accomplish through cooperation, resilience, and a collective commitment to advancing our understanding of the cosmos. Looking ahead, lunar exploration is poised to enter a new and exciting era. NASA's Artemis program represents the next giant leap, with ambitious plans to return astronauts to the lunar surface, this time including the first woman and the next man, to establish a sustainable human presence by the end of this decade. Artemis aims not just to revisit the moon, but to lay the groundwork for a permanent base that can support ongoing scientific research, resource utilization, and serve as a launchpad for future missions to Mars and beyond. The program's goals reflect a strategic vision that transforms the moon from a distant goal into an accessible, vital part of humanity's spacefaring future. Beyond NASA, other countries and private enterprises are charting their own paths to the moon, each bringing fresh innovation and enthusiasm. Nations such as China, Russia, the European Union, Japan, and India continue to develop lunar exploration missions with increasingly sophisticated technologies and scientific objectives. Private companies are also entering the lunar arena with ambitious plans for mining the moon's abundant resources and developing lunar tourism, envisioning a future where the moon becomes not just a scientific outpost, but a bustling hub of economic activity and human presence. In conclusion, the exploration of the moon is far from a closed chapter in human history. It is an ongoing cosmic journey that has reshaped our understanding of the universe and our place within it. From the earliest robotic landers to the historic Apollo missions, and continuing with India's Chandrayaan-3 and today's Artemis program, each mission has contributed to a vast and intricate tapestry of knowledge. This ever-expanding body of discovery continues to unravel the moon's mysteries, inspiring generations and fueling our ambitions. As we look toward the future, the moon remains an enduring symbol of human exploration, an eternal beacon of scientific wonder and a guiding light that draws us toward the stars. It is a testament to our unwavering curiosity, our boundless capacity for innovation, and our shared destiny as explorers of the cosmos. Lunar exploration transcends mere scientific pursuit. It embodies the very essence of human spirit, our desire to dream, to discover, and to reach ever higher into the heavens. This saga invites all of us to imagine a future where humanity thrives beyond Earth, united in our quest for knowledge and adventure, ever ready to embrace the unknown. The moon, once a distant and mysterious orb, now stands as a gateway to the infinite possibilities that lie ahead in the vast expanse of space. Imagine a star so enormous that it's expanding beyond the orbits of Mercury and Venus, reaching dangerously close to Earth itself. Picture standing on the horizon at sunrise, where half the sky is filled with its blazing light. In the vast cosmic tapestry, where stars shimmer like ancient stories painted across the velvet night, a new chapter is being written. One linked to the visionary entrepreneur and tech titan Elon Musk, in a revelation that has sent ripples through the world of science and astronomy. Musk has sparked excitement and wonder among stargazers everywhere. His astonishing announcement unveils a celestial giant, the burning supergiant star Betelgeuse. This star, glowing with fiery intensity, is capturing the imagination of millions and reminding us just how dynamic and mysterious our universe truly is. Perched majestically on the shoulder of the iconic constellation Orion, Betelgeuse has long been one of the most captivating stars visible in our night sky. For countless generations, stargazers, astronomers, and dreamers alike have gazed up at this fiery beacon, its vibrant reddish-orange glow standing out boldly among the twinkling tapestry of distant suns. Its enormous size and brilliant luminosity have woven themselves into myths, legends, and scientific fascination, inspiring awe and curiosity across cultures and centuries. Yet, in recent times, Betelgeuse has been anything but predictable. Its brightness has fluctuated wildly, dimming and brightening in ways that have left scientists both puzzled and excited. These enigmatic changes have sparked widespread speculation about what the future holds for this stellar giant. Is it on the verge of a spectacular transformation? Could it soon explode in a brilliant supernova, outshining the moon and becoming visible even in daylight? Such questions have ignited a fresh wave of interest not only among the scientific community but also among the public, eager to witness a cosmic event of unimaginable scale. Enter Elon Musk, a visionary entrepreneur whose name is synonymous with pushing the boundaries of technology and space exploration. Musk's recent revelation about Betelgeuse has reverberated through the scientific world and beyond, rekindling fascination with this enigmatic star. His insights bring new perspective to Betelgeuse's role in the grand cosmic story and highlight how much we still have to learn about the life cycles of stars and the dynamic universe around us. Betelgeuse is a star nearing the end of its life, having exhausted much of the hydrogen fuel at its core that powers the nuclear fusion giving it energy. As it ages, it expands enormously. So large, in fact, that if it were placed at the center of our solar system, it would engulf the orbits of Mercury and Venus and reach dangerously close to Earth's orbit. Imagine looking out at the horizon and seeing the sunrise stretching across half the sky, a sight both beautiful and humbling. This enormous star is a vivid reminder of the vast scales and forces at play in our universe. The fluctuations in brightness are believed to be caused by massive convection cells on Betelgeuse's surface, giant star spots, and eruptions of gas that change the star's appearance. But the most thrilling possibility is that these changes signal an impending supernova, a stellar explosion that will mark the death of Betelgeuse and the birth of new cosmic material. Such an explosion would be visible from Earth, creating a spectacular display and providing an unprecedented opportunity for scientists to study the life cycle of massive stars up close. Musk's announcement taps into this excitement and emphasizes the importance of continuing to explore and understand the cosmos. His vision, backed by advances in space technology and observation, opens the door to new possibilities. What if humanity could one day witness such events firsthand? What if we could harness this knowledge to travel farther, learn more, and uncover the mysteries of the universe that have long eluded us? In the grand tapestry of the cosmos, where countless stars shine like ancient stories etched across the velvet night, Betelgeuse stands out as a cosmic protagonist, a symbol of change, endurance, and the eternal cycle of creation and destruction. Its story reminds us that the universe is alive with movement and transformation, constantly challenging our understanding and inviting us to explore ever deeper. As we watch Betelgeuse's dramatic final chapters unfold, we are not just passive observers, but active participants in humanity's quest for knowledge and discovery. The tale of this burning supergiant star, brought to life anew by Elon Musk's revelations, is an invitation to dream bigger, reach further, and never cease to be amazed by the wonders of the universe. The staggering surge in Betelgeuse's brightness, a breathtaking 250% increase, has sent ripples through the scientific community, defying prior expectations and challenging our deepest understandings of stellar behavior and cosmic phenomena. This dramatic rise in luminosity is more than just a numerical figure. It resonates like the crescendo of a grand symphony, pulling humanity into a timeless cosmic narrative that stretches back to the dawn of the universe itself. As we delve deeper into the unfolding story of Betelgeuse, the very fabric of space and time seems to shift and unravel, unveiling secrets hidden in the heart of this magnificent celestial titan. Unlike the steadfast stars that punctuate the night sky with steady, unchanging light, Betelgeuse performs a mesmerizing and unpredictable dance of transformation. Its fiery surface ebbs and flows with intense variations, each surge and dimming a testament to the volatile processes raging within. Situated relatively close to our own solar system, cosmically speaking, Betelgeuse's proximity makes its dramatic outbursts of light all the more awe-inspiring. This semi-regular variable star pulses with a vitality that echoes the rhythms of life itself, unpredictable, captivating, and relentless. Its brilliance fluctuates in a cosmic heartbeat, marking its path as it journeys toward a monumental climax. A cosmic swan song, destined to culminate in a supernova explosion. This impending supernova is not just an ending, but a magnificent transformation. As Betelgeuse approaches this final act, it promises to light up the night sky with a brilliance that may outshine entire galaxies for a fleeting moment, reminding us of the incredible power and beauty of the universe's life cycles. In this radiant spectacle, the ancient star invites us to witness the profound and eternal dance of creation and destruction that shapes the cosmos. The impending explosion of Betelgeuse promises to be an event of truly epic proportions, one that could captivate the world and reshape our understanding of stellar life cycles. In recent years, this enigmatic star has drawn unprecedented attention, its mysterious and unpredictable changes in brightness sparking intense fascination and debate among astronomers worldwide. These unanticipated fluctuations in luminosity have thrown scientists into a whirlwind of curiosity, compelling them to unravel the complex celestial puzzle that Betelgeuse presents. Amid this cosmic intrigue, Elon Musk, a visionary luminary in his own right, turned his gaze toward the stars and offered a fresh perspective. By connecting the dots between various phenomena, Musk shed new light on the infamous Great Dimming events that shrouded Betelgeuse in shadow during 2018, 2019, and 2020. This puzzling dimming episode, which momentarily dulled the brilliance of the red giant, thrust the aging star into the global spotlight, hinting at the profound transformations unfolding within. Now, Betelgeuse has unfurled yet another enthralling spectacle, captivating stargazers and scientists alike with its radiant display. Its fluctuating glow serves as a cosmic beacon, signaling the star in the throes of an extraordinary metamorphosis. As the red giant edges closer to its final act, this spectacular celestial drama reminds us of the raw power and awe-inspiring beauty inherent in the universe's grand design. Betelgeuse has been amplifying its luminosity by over 50% at times, casting an ethereal and otherworldly glow across the vast canvas of our night sky. This celestial spectacle has mesmerized stargazers around the world, as the star's radiant bursts punctuate the darkness with an intensity rarely witnessed before. But the cosmic drama didn't end there. On May 20th, 2023, a vigilant cosmic sentinel known as Beetlebot sent a stunning alert. Betelgeuse's brilliance had surged by an astounding 142%, igniting waves of excitement and curiosity across the scientific community. Following this jaw-dropping revelation, subsequent observations pushed the boundaries even further, with reports confirming an extraordinary 150% increase in luminosity. This unexpected and dramatic escalation left astrophysicists and astronomers completely astounded as they scrambled to interpret the signals from this enigmatic stellar giant. Amidst this symphony of cosmic energy, one voice rose prominently: astrophysicist Andrea Dupre from the prestigious Harvard-Smithsonian Center for Astrophysics. She highlighted Betelgeuse's newfound stellar prominence, underscoring how this glowing titan continues to challenge our understanding of star behavior and the complex processes leading up to a supernova. This luminous celestial gem, Betelgeuse, has dramatically ascended the cosmic ranks, now shining as the seventh brightest star in the night sky, a remarkable leap from its usual position at 10th place. For generations, Betelgeuse has quietly graced the heavens, a familiar and steady beacon for stargazers. Yet today, it dazzles with renewed brilliance, captivating observers across both the southern and northern hemispheres with its intensified, almost hypnotic glow. As we stand in awe of Betelgeuse's radiant display, the insightful words of Dr. Sarah Webb, a distinguished astrophysicist from Australia's Swinburne University of Technology, resonate deeply. She reminds us that this extraordinary surge in brightness is not merely a fleeting spectacle, but a profound clue into the life cycle of massive stars, a glimpse into the complex, dynamic processes that govern their final stages before the ultimate cosmic event. Betelgeuse, Dr. Webb emphasizes, is revealing the climactic chapters in the life story of a colossal star, offering humanity an unprecedented spectacle of cosmic evolution at its most dramatic. This magnificent celestial phenomenon deepens our understanding of the universe by granting us a rare glimpse into the red giant's final act, the prelude to its magnificent supernova crescendo. The prospect of Betelgeuse's impending supernova fills both professional astronomers and amateur stargazers with eager anticipation. When this colossal explosion finally occurs, it could illuminate the night sky with a brilliance so intense that it would remain visible for an entire week, casting ethereal shadows in the darkness and captivating observers around the world. This mesmerizing possibility unites people across continents and cultures, transcending borders to remind us all of the awe-inspiring power and universal allure of the cosmos. As the story of Betelgeuse unfolds, we stand at a rare and extraordinary vantage point in history, just 650 light-years from this stellar giant, witnessing perhaps the final magnificent moments of one of the universe's greatest luminous titan. Betelgeuse offers us a rare front-row seat to witness the unfolding of an extraordinary cosmic drama. Heidi Morris, a renowned scientist at Los Alamos National Laboratory and a respected leader within the Peer-to Astronomers Club, highlights the profound privilege of our vantage point. She reminds us that the captivating fluctuations in Betelgeuse's luminosity have fascinated human observers for millennia, captivating cultures as diverse as the ancient Greeks and the Aboriginal Australians, each weaving their own stories around this brilliant celestial beacon. Adding to the intrigue, Elon Musk's discerning eye has detected intriguing patterns in Betelgeuse's brightness cycle, patterns that both echo ancient rhythms and hint at mysterious new behavior. Typically, Betelgeuse's luminosity has followed a relatively steady cycle of around 400 days, a rhythmic cosmic dance that has persisted with remarkable consistency over centuries. However, recent observations have revealed a much more dynamic and vivacious cadence, shifting every 130 days, signaling that the star is entering a new, more unpredictable phase. Meticulously documented by astrophysicist Andrea Dupree in 2019, Betelgeuse embarked on an uncommon and dramatic journey, marked by a powerful expulsion of its outer layers. This event sparked the beginning of its cryptic dance of light, a luminous spectacle that starkly departs from Betelgeuse's previously stable patterns and raises profound questions that challenge our established understanding of stellar behavior. The aftermath of this spectacular event, characterized by a series of fluctuations and transformations in the star's brightness and structure, remains largely uncharted territory. It beckons researchers, astronomers, and scientists worldwide to delve deeper into the heart of this celestial enigma. Every new observation peels back layers of mystery, pushing the boundaries of astrophysical knowledge and offering fresh insights into the life cycles of massive stars. As Betelgeuse continues to shimmer and evolve before our very eyes, it serves as a powerful reminder of the universe's endless capacity for surprise and wonder. This cosmic spectacle not only enriches our scientific understanding, but also ignites the imagination, inspiring us to ponder the grand and timeless dance of the stars. As the surface of Betelgeuse gradually convalesces from the recent upheaval, it offers astronomers and scientists an invaluable glimpse into the intricate and often turbulent dynamics that define the final phases of a red giant star's life. Jerry Goldberg, an esteemed astrophysicist, approaches the star's fate with cautious contemplation. While the prospect of Betelgeuse's supernova crescendo, an explosive finale of epic proportions, remains a tantalizing possibility, Goldberg reminds us that this cosmic event may not be imminent. In fact, the timeline for such an eruption could span anywhere from 10,000 to 100,000 years, a vast expanse that shatters any notions of immediate fireworks and serves as a humbling reminder of the immense scales of time that govern the lives of celestial giants. The saga of Betelgeuse is deeply intertwined with human history, a cosmic thread woven through over 2 millennia. Its shifting hues and fluctuating brightness have long captured the imaginations of stargazers and storytellers alike. From ancient Egyptian hieroglyphs to the myths of classical Greece, Betelgeuse's luminous presence has illuminated cultural narratives across civilizations and epochs. This fiery star's radiant charm transcends geographic and temporal boundaries, touching the hearts and minds of humanity through the ages. Amidst the ebb and flow of Betelgeuse's luminosity, a singular question lingers in the collective consciousness. When will the grand spectacle of its supernova finally unfurl? While scientific speculation abounds, the truth remains cloaked in cosmic mystery. Every observation brings us closer to understanding this enigmatic star's complex behavior, yet the precise timing of its final explosive act remains one of the greatest unanswered questions in astrophysics. As we stand beneath the vast velvet sky, watching Betelgeuse's brilliance wax and wane, we are reminded not only of the impermanence of even the mightiest stars, but also of the enduring human fascination with the cosmos. A fascination that fuels our quest for knowledge and connects us across time and space to the very heart of the universe. Speculation abounds among experts, yet voices of doubt persist. Dr. Grower, an associate professor of astronomy, asserts that predicting such stellar fireworks remains far beyond our current scientific grasp. The intricate science of stellar timekeeping eludes even the most advanced astronomers, leaving the secrets of when Betelgeuse will dazzle the cosmos in supernova splendor locked away in deep cosmic silence. Betelgeuse's stellar saga is a tale of profound cosmic intricacy, an epic narrative that continues to unfold before our very eyes. As a red giant, Betelgeuse orchestrates a grand symphony of fusion, melding elements like helium, carbon, oxygen, silicon, and iron within its colossal core. This celestial alchemy takes place under staggering pressure, where helium slowly fuses into carbon over thousands of years in a mesmerizing slow dance. This rhythmic process marches onward, birthing heavier and heavier elements until iron finally emerges, signaling the star's inexorable fate. Elon Musk, ever the visionary, explains that Betelgeuse's destiny hinges on a universe-defining binary choice: to collapse into either a black hole or a neutron star. Chemical cues gleaned from the star's atmospheric makeup suggest that Betelgeuse is currently in its helium-carbon fusion phase. Yet the innermost workings of this cosmic ballet remain hidden from our earthly gaze. Astrophysicist Jared Goldberg, the cautious explorer of cosmic secrets, muses thoughtfully on Betelgeuse's fate. Despite the tantalizing clues, much about the star's internal mechanisms and timeline remains cloaked in mystery. It is this blend of uncertainty and discovery that keeps scientists riveted as each new piece of data draws us closer to understanding one of the universe's most captivating enigmas. The ultimate detonation of Betelgeuse, the stellar crescendo of its life, might transpire within a vast time span stretching from 10,000 to 100,000 years. This grand cosmic event is not necessarily imminent, rather it unfolds on a timescale measured in eons, far beyond the reach of human lifetimes. The science of stars remains a domain filled with uncertainty, where predictions are inherently complex and the mysteries of celestial time are elusive and ever-shifting. Betelgeuse itself is a star of extraordinary proportions, defying conventional norms in multiple ways. As a colossal red supergiant, its lifespan has been lived fast and furious compared to the Sun's more stately and prolonged existence. Within a mere 10 million years, Betelgeuse has evolved into its current gargantuan state, bearing the immense weight of its colossal mass. Yet, despite its turbulent youth, its fate has already been inscribed in the cosmic ledger. An explosive climax so powerful it could potentially eclipse entire galaxies. A cataclysmic event that is as inevitable as it is shrouded in mystery, particularly regarding its exact timing. Elon Musk's keen insight adds a compelling layer to this cosmic narrative, suggesting that NASA's InSight mission casts a long shadow over Betelgeuse's anticipated climax. According to the agency's projections, the star is unlikely to unleash its supernova spectacle for another staggering 100,000 years, a timeline that utterly dwarfs human history and existence. This revelation invites us to marvel at the slow, majestic rhythms of the universe, where monumental cosmic events unfold on scales both humbling and awe-inspiring. Though the anticipated supernova of Betelgeuse is projected to occur within the next 10,000 to 100,000 years, a span that dwarfs human lifespans and historical epochs, Heidi Morris reminds us that, even within just 10,000 years, significant change could be underway. This possibility beckons humanity onward in its scientific pursuit of understanding the cosmos. As we stand on the precipice of cosmic wonder, it is crucial to remember that the light we currently observe from Betelgeuse is not a snapshot of its present state, but a view reaching back some 600 years into the past. The photons traveling across the vastness of space may already be conveying a final message. Betelgeuse could have exploded long ago, its supernova spectacle unfolding unbeknownst to us here on Earth. While this remains speculative, the notion ignites the fires of curiosity, urging us to consider that the star's cataclysmic fate might already be written in the depths of space. Throughout cosmic history, the universe has surprised us time and again with unexpected revelations. The supernova of 1987 serves as a vivid reminder. This dazzling explosion, which erupted from a brilliant blue star in a distant galaxy, defied predictions and challenged scientific expectations. Such humbling and awe-inspiring surprises underscore the ever-changing, dynamic nature of the cosmos. As we continue to observe Betelgeuse and its colossal celestial brethren, our understanding accelerates, propelled not just by the promise of a spectacular explosion, but by the unfolding story of stellar evolution itself. An ongoing cosmic drama that deepens our appreciation of the vast, mysterious universe we inhabit. Betelgeuse's current behavior of dimming and flaring reveals profound physical processes unfolding within the star, granting researchers and scientists an unprecedented glimpse into the intricate complexities of a massive star's life cycle. Once known for its dependable 400-day cycle of brightness variations, Betelgeuse has now deviated from this familiar rhythm, sparking intense intrigue and opening new frontiers in stellar astrophysics. While on the surface these fluctuations may appear as a graceful cosmic ballet of light, there is a deeper and more urgent narrative emerging. On June 2, 2023, astronomers witnessed a startling twist. Betelgeuse's changing luminosity now hints at its entry into the late stages of the core carbon-burning phase. This critical revelation challenges long-held assumptions and introduces an added layer of complexity to the star's final act. In this period of cosmic whispers and fluctuating radiance, Betelgeuse finds itself caught in a remarkable conundrum of overlapping evolutionary stages. This unique phase offers astronomers around the globe a rare opportunity to witness in real time the unfolding drama of a star's transformation as it approaches the end of its life. The so-called carbon curtain call, signaling the exhaustion of carbon fuel within the star's core, marks a pivotal milestone in Betelgeuse's cosmic journey. This moment heralds the approaching grand finale, a colossal supernova explosion that will reverberate across space and time. As Betelgeuse's final act unfolds, it takes an audacious turn, one that will captivate the scientific community and stargazers alike, illuminating the night sky with a spectacular burst of energy and light unlike anything witnessed before. The anticipation of this event deepens our understanding of stellar evolution, reminding us of the profound and dynamic forces at work in the universe. This spectacular phase of Betelgeuse's life, marked by a dramatic shift away from the familiar helium-burning processes, promises to illuminate the cosmos and captivate the imaginations of all who gaze skyward. It invites us to venture into uncharted territories of stellar physics, challenging existing models and inspiring fresh exploration into the life cycles of massive stars. As this cosmic drama unfolds, Elon Musk's insights remind us that Betelgeuse is not alone on the celestial stage. Other red supergiants, such as Eta Carinæ, loom as potential actors poised to steal the spotlight, possibly exploding as supernovae before Betelgeuse does. Statistically, our Milky Way galaxy is expected to host a supernova event roughly every 50 years. Yet the past 4 centuries have defied this pattern, suggesting that the universe's next grand cosmic performance is overdue. Betelgeuse's significant dimming in 2020 added a fascinating and mysterious chapter to this unfolding story. The Great Dimming event of late 2019 and early 2020 broke away from the star's usual brightness variations, puzzling astronomers and igniting a wave of scientific curiosity and global attention. This unprecedented behavior set the stage for an intricate cosmic puzzle, one that continues to challenge our understanding and fuels the collective excitement of the astronomical community worldwide. Dimming by an astonishing 60% within just a few months, Betelgeuse's dramatic transformation unfolded with breathtaking speed, captivating humanity's gaze and igniting a whirlwind of scientific investigation. But what secrets lie beneath this celestial spectacle? To unravel the mysteries of this cosmic enigma, dedicated researchers turned powerful observatories toward the star, seeking to peer into the heart of Betelgeuse's astonishing changes. High-resolution images captured by the Very Large Telescope, VLT, in Chile, played a crucial role in this endeavor. Over several months, these snapshots revealed dynamic shifts in Betelgeuse's surface, providing astronomers with an unprecedented look into the star's upheaval. Using the SPHERE instrument, one of the most advanced imaging tools available, scientists captured intimate portraits of this celestial giant, unveiling both its radiant beauty and the hidden mechanisms behind its sudden dimming. The culmination of these observations led to a groundbreaking discovery, a monumental convective plume surging from deep within Betelgeuse's fiery depths. This colossal outburst of stellar material, like a massive bubble rising through boiling water, appeared to cloak the star in a veil of dust, partially obscuring its brilliant light from our view. This convective event not only illuminated the physical processes driving the star's unusual behavior, but also offered a tangible explanation for the mysterious Great Dimming, bridging the gap between observation and theory in the ongoing saga of Betelgeuse. Spanning over 1 million miles, this colossal convective plume set the stage for Betelgeuse's unprecedented dimming event. The sheer magnitude of this stellar eruption, about 400 billion times more massive than a typical coronal mass ejection from our own sun, left scientists both awestruck and deeply curious about the star's stability and what the future might hold. As researchers meticulously analyzed the data, a complex tapestry of cosmic dynamics gradually unfolded. This massive ejection disrupted Betelgeuse's delicate equilibrium, generating intense turbulence that sent shockwaves rippling through the star's plasma and magnetic fields. The aftermath was an enigmatic display of luminosity fluctuations and oscillations that defied simple explanation. In the quest to unravel this cosmic mystery, the high-resolution images captured by the Very Large Telescope, VLT, paired with advanced computer simulations, proved indispensable. Over 10,000 simulations were run, each weaving together a compelling narrative that matched the observed data. These models revealed a dramatic interplay, a gargantuan convective plume rising from deep within the star, a massive surface ejection of stellar material, and a surrounding cosmic dust cloud, all choreographing the unprecedented dimming of Betelgeuse. Astrophysicist Miguel Montages from the Paris Observatory illuminated the dimming mystery further by proposing a unifying theory. He suggested that these factors were not isolated phenomena, but part of a cosmic waltz, a complex, interconnected dance of stellar forces that culminated in the spectacular and puzzling dimming event observed by astronomers around the world. Miguel Montages likened Betelgeuse's recent upheaval to an unbalanced washing machine drum, where the star's disrupted equilibrium generated ripples that echoed dramatically across its vast surface. As the dense dust cloud, born deep within Betelgeuse's fiery interior, obscured its southern expanse, a cosmic drama of unprecedented proportions unfolded before the eyes of the world. This extraordinary confluence of stellar events sparked immense curiosity and fascination among astronomers, who painstakingly pieced together the cosmic puzzle through meticulous analysis and dedicated research. Elon Musk's profound appreciation for Betelgeuse's significance in the tapestry of astronomy resonates through the ages. He draws attention to the star's enduring influence on human culture, highlighting its role in shaping ancient myths and stories. From Roman poet Horace's mention of Betelgeuse as Orion's troubled star over 2 millennia ago, to the observations of Aboriginal Australians some 65,000 years in the past, Betelgeuse's variable nature has woven itself deeply into humanity's collective consciousness. The journey of Betelgeuse through the annals of history is one marked by continuous discovery and transformation. In the 1830s, the pioneering observations of John Herschel opened a new era in astrophysics, providing a scientific foundation for understanding this enigmatic red supergiant. Herschel's work laid the groundwork for generations of astronomers who have sought to unravel the mysteries of Betelgeuse and its spectacular cosmic behavior. His pioneering insights into Betelgeuse's variable brightness marked a crucial milestone in humanity's centuries-long journey into understanding the intricate physics of celestial bodies. From the earliest telescopic observations to the sophisticated astrophysical models of today, Betelgeuse has captured the curiosity of scientists and stargazers alike. Yet it is within the last 200 years that this magnificent red supergiant has ascended to the center stage of cosmic intrigue. As generations of astronomers trained their instruments and telescopes toward the shoulder of Orion, Betelgeuse's rhythmic fluctuations became the subject of intense scrutiny and fascination. The star's behavior, characterized by a well-established 400-day luminosity cycle, punctuated by unexpected anomalies, adds a unique and dynamic thread to the vast cosmic tapestry. Each variation in brightness tells a story, an eloquent message from the depths of a dying star, echoing across the vastness of space and time. These variations are more than just scientific curiosities. They are windows into the life cycles of some of the universe's most colossal and mysterious giants. Visionary leaders in science and technology, such as Elon Musk, have helped propel this narrative forward, bringing renewed attention and innovative thinking to the study of Betelgeuse. Musk's passion for space exploration and his profound understanding of cosmic phenomena have inspired a new wave of curiosity and research. By combining traditional astrophysical observations with cutting-edge technology and bold imagination, the veil over Betelgeuse's mysteries has begun to lift, revealing glimpses of the star's complex internal processes and the extraordinary cosmic forces shaping its fate. Today, as we stand at the precipice of unprecedented discovery, Betelgeuse's enigmatic behavior continues to captivate not only the scientific community but also the public imagination. Its dramatic dimming episodes and sudden flares serve as cosmic signposts, offering profound insights into the turbulent and often violent processes occurring within the star's enormous interior. These luminous fluctuations are not random, but are the result of intricate interactions between nuclear fusion reactions, magnetic fields, and convective currents. An elaborate cosmic dance that reflects the star's gradual journey toward its ultimate destiny. As astrophysicists meticulously analyze data from advanced telescopes, space probes, and computer simulations, a new era of understanding dawns. This era bridges the gap between the ancient myths and legends that once sought to explain the stars and the precise empirical science that now deciphers their secrets. Betelgeuse, a star woven into the very fabric of human culture for millennia, from Roman poets to indigenous storytellers, now stands as a beacon of modern astrophysics, symbolizing the unending quest for knowledge that defines humanity. In anticipation of Betelgeuse's eventual supernova explosion, a cataclysmic event that will illuminate the cosmos with an unparalleled brilliance, scientists, astronomers, and enthusiasts worldwide watch with bated breath. This impending cosmic spectacle promises not only to deepen our understanding of stellar evolution, but also to unite humanity in shared wonder and awe. Elon Musk's visionary perspective reminds us that Betelgeuse's story is far from over. Each new observation, each breakthrough, each revelation draws us deeper into the star's cosmic narrative, inspiring us to reach further into the depths of space and time. In this grand exploration, Betelgeuse serves as both a symbol and a catalyst, igniting our collective curiosity and challenging us to seek answers to the fundamental questions posed by the universe. Thus, as we gaze upward into the night sky, we are invited to partake in an epic cosmic saga, one that spans millennia, bridges cultures, and beckons us to continue exploring the infinite mysteries that lie beyond our world. Betelgeuse's luminous dance is not only a spectacle to behold, but a profound reminder of our place in the cosmos, urging us onward in our eternal journey of discovery. In the heart of 1977, a new chapter in human exploration began, a moment destined to echo across the stars. That year, NASA launched two extraordinary spacecraft, Voyager 1 and Voyager 2. These robotic pioneers were more than machines. They were ambassadors of Earth, sent forth to explore the unknown edges of our solar system and beyond. Their mission? To journey where no human-made object had ever gone before, and to reveal the secrets of the great cosmic frontier. At the time of their launch, the outer planets, Jupiter, Saturn, Uranus, and Neptune, remained cloaked in mystery. No spacecraft had ventured so far, and much of what we knew came from telescopic observation alone. Voyager 1 and 2 were tasked with changing that. Each carried a golden record, inscribed with the sounds, music, and greetings of Earth, a time capsule intended for any intelligent life they might encounter. Their journey began with flybys of the giant planets. The Voyagers captured breathtaking images of Jupiter's turbulent storms, the complex ring system of Saturn, the icy beauty of Uranus, and the deep blue hues of Neptune. They discovered active volcanoes on Jupiter's moon Io, the possibility of subsurface oceans on Europa, and the stunning hexagonal storm at Saturn's pole. Yet their mission didn't end there. Decades later, Voyager 1 became the first human-made object to cross into interstellar space, leaving behind the heliosphere, the protective bubble created by our sun's solar wind. Now, Voyager travels through the space between stars, still transmitting data back to Earth across a distance of over 14 billion miles. Voyager 1, now over 14 billion miles from Earth, continues to astonish humanity. Not with images this time, but with sound. In 2021, it detected a faint, persistent cosmic hum, an eerie, low-frequency vibration that echoed through the silence of interstellar space. This discovery was not just poetic, it was revolutionary. Recorded using Voyager's plasma wave subsystem, the hum is not static, nor is it an artificial signal. It's a steady oscillation in the plasma density of the interstellar medium, the vast, invisible ocean of charged particles that exists between stars. Scientists describe this hum as the interstellar wind's song, a kind of background radiation from the interactions between dying stars, galactic particles, and the remnants of ancient supernovae. This wasn't the first time Voyager 1 heard something strange. Back in 2012, when it crossed the heliopause, the boundary where the sun's influence ends, it also captured a burst of plasma waves, indicating its transition into interstellar space. But the 2021 hum was different. It was constant, low-level and ongoing. A faint, ghostly soundtrack that had persisted for nearly 3 years before it was identified in the data. So what does this mean? To scientists, it's a breakthrough. It proves that interstellar space is not a void, but rather a dynamic environment filled with movement, pressure and sound, albeit at frequencies no human ear can detect. The cosmic hum helps researchers map the density and pressure of interstellar plasma, potentially unveiling new physics about the behavior of matter in deep space. To the public, however, the hum evokes something more primal, a sense of connection to the cosmos. For the first time, we're not just seeing space or measuring it, we're hearing it. And that auditory link between Earth and the stars taps into something deeply human, the need to listen, to understand, and to feel part of a greater whole. But the cosmic hum is only one part of Voyager 1's unfolding legacy. In addition to the plasma wave readings, the probe continues to send back data on cosmic rays, magnetic fields, and shock waves from solar outbursts that reach even the edges of our solar bubble. These readings help scientists model the protective barrier around our solar system, essential knowledge for planning future missions beyond Mars and even beyond the Kuiper Belt. And then, of course, there's the possibility, however remote, that Voyager may one day intercept or detect a signal of artificial origin, something that challenges our understanding of life and intelligence in the universe. While the current is believed to be natural, it has nonetheless rekindled discussions about the limits of our knowledge and what else might be out there waiting to be heard. The Voyager missions have never been just about data, they're about presence. Voyager 1, now the farthest human-made object in history, carries with it the Golden Record, a time capsule of Earth sounds, greetings and music designed for any intelligent life that might find it. Ironically, while we sent out our own audio into the stars, Voyager has now returned the favor with a song of its own from the vast cosmic sea. In the end, the cosmic hum is not just a phenomenon, it's a reminder that space is not silent, that even in the darkest corners of the universe, something stirs, something speaks, and thanks to Voyager 1, we are listening. Yet even at this unimaginable distance, Voyager 1 continues to whisper back to us, transmitting faint signals that traverse the cold, empty void of interstellar space. Each transmission is a miracle of engineering, a testament to the vision of the scientists and engineers who launched this mission over 4 decades ago. What started in 1977 as an ambitious plan to explore the outer planets has now become humanity's first true foray into the space between the stars. As Voyager 1 drifts through the interstellar medium, It no longer feels the warm embrace of our sun's solar wind. It is beyond the heliopause, where the sun's influence gives way to the galactic environment. Here, it samples the raw, untamed particles that float through the Milky Way. Charged remnants of ancient stars, shockwaves from distant supernovae, and the whispers of cosmic radiation that echo across time and space. What makes Voyager 1's journey even more astonishing is its continued functionality. Designed for a mission that was only supposed to last 5 years, this probe has defied all expectations. Its radioisotope thermoelectric generators still power its instruments, albeit with diminishing strength. Every byte of data it sends is cherished by scientists, representing a glimpse into a region of space that no probe had ever reached before. Its discoveries continue to reshape our understanding of the universe. From detecting plasma waves in the interstellar medium to measuring cosmic ray intensity far beyond the planets, Voyager 1 gives us rare insights into the environment outside our solar bubble. And perhaps most hauntingly of all, it has captured the sound of the cosmos. The low, steady hum of interstellar space, a phenomenon previously undetected and deeply profound. Meanwhile, its twin, Voyager 2, follows its own path through the cosmos, having taken a slightly different trajectory that allowed it to visit all 4 gas giants, Jupiter, Saturn, Uranus and Neptune, before departing the heliosphere in 2018. The 2 spacecraft now travel alone thousands of miles apart, but forever linked in purpose and destiny. Together, they are humanity's ambassadors to the stars. What lies ahead for Voyager 1 is unknown. It will eventually run out of power, perhaps in the next few years, and fall silent, drifting endlessly through the galaxy as a ghost ship of Earth, carrying with it the golden record, a carefully curated time capsule of music, images and greetings, in 55 languages, meant for any intelligent life that may one day find it. In a way, Voyager 1 is not just a machine, it is a message from one species on one small planet, reaching out to the cosmos with hope, curiosity, and the desire to be known. As we look to the future, to missions like Artemis, Dragonfly, Europa Clipper, and beyond, we remember that it was Voyager that laid the foundation. It dared to venture where nothing had gone before, and through it, we dared to ask the most profound of questions. What lies beyond our world? And are we truly alone? Stay with us as we continue to chronicle Voyager's journey and explore the mysteries it unveils. The universe is vast, and our journey is just beginning. Regions of interstellar space. This hum, a persistent, low-frequency vibration, was unlike anything previously recorded. It was not the radio chatter of planets or the static of solar winds. Instead, it was a subtle, continuous resonance emanating from the interstellar medium itself. NASA scientists were intrigued. This phenomenon, now referred to as the interstellar plasma wave hum, provided direct evidence that Voyager 1 had indeed crossed into a new realm of space. The hum was created by oscillations in the ionized gas or plasma that fills the vast space between the stars. This marked the first time humanity had directly heard the natural frequencies of interstellar matter. Unlike the dramatic bursts of plasma activity observed near the Sun, this hum was steady, unwavering, and eerily calm. Its presence suggested that the interstellar environment was far from empty, Rather, it was alive with invisible forces and particles, shaped over billions of years by supernova explosions, stellar winds, and galactic tides. This discovery not only confirmed Voyager 1's entry into interstellar space, but it also opened a new chapter in space science. Scientists could now map the density and behavior of interstellar plasma, something previously relegated to theoretical models. With each passing month, Voyager 1 continued to collect data that offered unprecedented insights into how our solar system interacts with the greater galaxy. Meanwhile, Voyager 2, Voyager 1's tireless sibling, pressed on through the darkness. Its journey past Uranus and Neptune had already yielded groundbreaking discoveries. The tilted magnetic field of Uranus, the supersonic winds of Neptune, and the detection of previously unknown moons and rings. Now, as Voyager 2 moved beyond the heliosphere, it began collecting complementary data on plasma density, magnetic field strength, and galactic cosmic rays, allowing researchers to compare conditions at different interstellar locations. Together, the Voyagers act as dual sentinels, probing the galactic frontier and transmitting scientific gold back to Earth. Their findings are helping us understand the nature of the heliopause, the outer boundary where the solar wind is no longer strong enough to push against the interstellar medium. This region, once mysterious and undefined, is now being mapped and measured inch by inch, thanks to these two robotic explorers. Incredibly, even after over 45 years in space, both Voyagers continue to operate, despite dwindling power supplies and aging technology. NASA's engineers have had to make tough choices, turning off non-essential instruments one by one to conserve energy. Yet the core systems that monitor cosmic radiation, magnetic fields and plasma waves remain active, providing invaluable data for humanity's understanding of the universe. The story of the Voyager probes is not just one of science and engineering. It is a story of perseverance, of vision, and of our species' eternal desire to reach beyond the known. These spacecraft have become cosmic time capsules, sailing into the void with Earth's message etched on the golden record, a greeting to any life forms that might one day encounter them. As Voyager 1 listens to the hum of the universe and Voyager 2 silently travels ever farther, we are reminded of the words of Carl Sagan: "Somewhere something incredible is waiting to be known." Stay with us as we continue to follow their journey beyond the stars. This revelation, that space is not the silent void we once imagined, has profound implications. For decades, interstellar space was presumed to be a vacuum of stillness, where silence reigned supreme. But Voyager 1's sensitive plasma wave instrument reveals something far more dynamic and alive. The interstellar medium is not a static backdrop. It is a living ocean of particles and waves, vibrating with the faint but persistent heartbeat of the galaxy. What makes this ether even more fascinating is its stability. It doesn't roar like a solar storm or flare unpredictably like a quasar. Instead, it maintains a narrow frequency range, about 300 mHz, like a whisper echoing endlessly through a cosmic canyon. This monotony, though subtle, is remarkably consistent. It implies that the density of interstellar plasma may be more uniform than previously believed, or at least not as chaotic as some models had once predicted. Even in the stillness, Voyager 1 detects gentle fluctuations, tiny shifts in pitch and intensity, like ripples spreading across the surface of a still lake. These nuances help scientists estimate the density of electrons in the plasma and, more importantly, how that density changes as the spacecraft continues to push farther into the galaxy. But the significance of these findings goes beyond plasma physics. The very fact that we can now hear interstellar space reshapes our sensory relationship with the cosmos. It adds a new layer to our understanding: sound. Not sound in the traditional sense, for space is airless, but electromagnetic oscillations converted into audio by Voyager's instruments. This cosmic hum becomes a kind of auditory fingerprint of the universe, a melody played by the particles that once formed stars, planets, and perhaps life itself. This discovery has even begun to influence other areas of research. Astrophysicists are now considering how galactic magnetic fields, remnants of ancient supernovae, and interstellar turbulence contribute to the structure and music of this vast expanse. It hints at a galactic ecology where stars, gas clouds, and even black holes may all play a role in shaping the invisible symphony of the universe. And then there's the poetic beauty of it all. A spacecraft built by human hands, launched in 1977 with the computing power of a pocket calculator, now floating alone through the interstellar abyss. Glistening, still functioning, still responding, still transmitting data across billions of miles. It is a technological ghost ship, piloted by no one, guided only by the last flickers of power from its aging radioisotope generator, yet it continues to unveil the deep whispers of the universe. Voyager's instruments were never originally designed to function this far from home. They were meant to survive the planetary tour of the late 20th century, Jupiter, Saturn, and perhaps beyond. But these resilient systems have defied time and expectation, and now serve as humanity's oldest eyes and ears in deep space. In the years ahead, this cosmic hum will continue to play, and Voyager 1 will keep listening until its power wanes and silence finally falls. But even then, the data it has sent will remain, echoing in our databases and our dreams, a sonic imprint of the stars between stars. So as we contemplate these faint vibrations from the edge of the sun's domain, let us remember, space is not empty. It sings, and thanks to Voyager, we are finally beginning to hear its song. It appears that such moments of tranquility within the interstellar medium occur with far greater frequency than previously imagined. The universe, it seems, has a hidden, almost poetic rhythm, one that Voyager 1's sensitive sensors have now unveiled for the first time in human history. As we stand on the precipice of more profound cosmic discoveries, one fact remains constant: the unwavering journey of the Voyager probes. Their relentless quest for knowledge, spanning nearly 5 decades, is a testament to human curiosity and ingenuity. However, this incredible odyssey is not infinite. The Voyagers are expected to continue their scientific activities only until around 2025. By the 3030S, they will have ventured so far beyond our blue planet that communication with Earth will become impossible, the faint signals lost in the vastness of space. Yet, even as their voices fade into silence, their legacy will endure. Encapsulated in the iconic Voyager Golden Records, time capsules of humanity, the probes carry a message of our existence, destined to drift through the cosmos for hundreds of millions of years. These records, inscribed with sounds and images from Earth, stand as a beacon to any distant civilization that might encounter them. bearing witness to the achievements, hopes and dreams of humankind, long after our era has faded into history. Turning our gaze back closer to home, we cast our minds to a moment forever etched into the annals of human achievement. July 20th, 1969. It was on this historic day that two intrepid astronauts, Neil Armstrong and Buzz Aldrin, took humanity's first footsteps on a foreign celestial body, the Moon. Armstrong's iconic words, "That's one small step for man, one giant leap for mankind," resonated across the world, igniting a flame of wonder and possibility in the hearts of millions. In the wake of this momentous event, ambitious plans were laid out. Plans for numerous lunar landings and the ultimate goal of establishing a permanent human presence on the Moon. This era marked the dawn of a new frontier where science, technology and human spirit combined to push beyond the boundaries of Earth. The Apollo missions not only expanded our understanding of the lunar surface, but also laid the groundwork for future exploration, inspiring generations to dream bigger and reach further. As we reflect on these extraordinary voyages, from the silent cosmic hum captured by Voyager 1 in the distant interstellar medium, to the footsteps left by humans on the lunar soil, one truth stands clear. Exploration is woven into the fabric of our species. It is this insatiable desire to understand the unknown, to connect with the universe beyond our blue planet, that drives us forward. And now, as new missions prepare to revisit the Moon and venture even further, humanity once again stands at the threshold of discovery, ready to unlock the next chapter in our cosmic story. Presence on our satellite, however, the years have passed, and the last manned excursion to the Moon occurred nearly half a century ago. Yet, the aspirations of several countries and space agencies remain undiminished. Their vision to return to the Moon and establish permanent lunar stations while harnessing the Moon's valuable resources continues to inspire innovation and exploration. This vision, however, is not without its formidable challenges. Establishing a sustainable human presence on the Moon requires vast resources: energy to power habitats and equipment, water for consumption and agriculture, and a reliable supply of breathable air. Among these challenges, one obstacle looms larger than the rest: the hostile lunar environment itself. The Moon's surface is marked by extremes that defy imagination. During the lunar daytime, temperatures can soar to nearly 250 degrees Fahrenheit, scorching everything in their path. In stark contrast, lunar nights plunge into bone-chilling cold, with temperatures plummeting to almost minus 275 degrees Fahrenheit. These extreme conditions pose a monumental challenge to human exploration and habitation, testing the limits of engineering and human endurance alike. Yet, hidden beneath the barren lunar surface, within the labyrinthine passages and caves formed by ancient lava flows, a potential solution may lie dormant. Recent probe images and data have hinted at the existence of these subterranean lunar realms. Vast networks of winding depressions and skylights, circular holes formed when cave ceilings collapsed. These skylights, with diameters ranging from about 50 to 500 feet, could very well serve as entrances to extensive underground cavities, potentially shielding future lunar settlers from the harsh surface extremes. To assess the viability of these lunar caves as potential habitats, scientists embarked on detailed missions to uncover their temperature profiles and environmental condition. One such study focused on a skylight located near the lunar equator, a collapse hole that could provide a natural gateway to a subterranean refuge. Preliminary observations indicate that these caves offer remarkably stable temperatures, buffered from the searing heat of lunar days and the frigid cold of lunar nights, making them an ideal environment for human habitation. If successfully utilized, these underground lunar caves could provide shelter from cosmic radiation, micrometeorite impacts, and the relentless temperature fluctuations that characterize the lunar surface. Harnessing such natural havens could revolutionize how we approach lunar colonization, turning the moon from a barren rock into a sustainable outpost for humanity. As we continue to explore these hidden lunar landscapes, the dream of establishing a permanent human foothold on the moon edges closer to reality, an endeavor that could one day serve as the launching pad for humanity's journey deeper into the cosmos. Approximately 300 feet deep and 300 feet in diameter, the lunar skylight captured by NASA's Lunar Reconnaissance Orbiter, LRO, has become a focal point of scientific curiosity and hope. Equipped with a thermal camera, the LRO provided invaluable data that allowed scientists to delve deeper into understanding the thermal dynamics within these intriguing formations. Using this data, researchers constructed detailed physical models of heat conduction to reveal surprising insights about the lunar environment. Despite the searing temperatures on the lunar surface during the day, where sunlight heats the exposed rock to over 280 degrees Fahrenheit, the bottom of this vast pit registered temperatures influenced not only by direct solar radiation, but also by thermal radiation emitted from the cave walls. This heat retention was expected, given the rocky enclosure, but what was truly remarkable lay just beyond this harsh environment. Within the cave adjacent to the skylight, temperatures held steady at a comfortable and stable 63 degrees Fahrenheit, a stark contrast to the extreme fluctuations on the surface. This constancy highlights a critical principle. The larger and more enclosed the cave, the more stable and temperate the environment it can maintain. Such findings underscore the immense potential of lunar caves as natural shelters for future human explorers. Beyond simply offering room temperatures comfortable enough for habitation, these subterranean havens provide critical protection against two of the moon's greatest hazards: meteorite impacts and cosmic radiation, both of which pose severe risks to life and technology on the surface. However, before humanity can fully embrace this vision of lunar colonization beneath the surface, these caves require comprehensive investigation. Future missions must validate their structural integrity, assess environmental conditions, and explore the feasibility of supporting long-term human presence. If successful, these lunar caves could become the cornerstone of humanity's next giant leap in space exploration. The prospect of humanity's future lunar outposts nestled within air-conditioned lunar caves is a tantalizing vision, one that could soon become a reality. These natural shelters promise to shield us from the moon's extreme temperatures, deadly cosmic radiation, and meteorite impacts, creating safe havens where astronauts might live and work for extended periods. As we dream of this next chapter in lunar exploration, our eyes simultaneously turn toward the farthest reaches of the cosmos. At the frontier of modern astronomy, the James Webb Space Telescope stands as a marvel of human ingenuity. Launched to unlock the deepest secrets of our universe, Webb's mission is to peer back in time, capturing the faint light of the earliest galaxies and luminous objects that sparked the cosmos into brilliance shortly after the Big Bang. Though Webb's scientific journey has only just begun, it has already transformed our understanding of the universe's infancy. Among Webb's most extraordinary discoveries is the detection of one of the oldest galaxies ever observed, scientifically known as Glass Z13. This ancient congregation of stars and cosmic matter formed a mere 300 to 400 million years after the Big Bang, making it an astonishing 30 million years older than the previous record holder, HD1. This groundbreaking finding not only underscores Webb's unparalleled observational power, but also heralds a new era in our quest to unravel the mysteries of cosmic origins. As we stand on the precipice of ever greater cosmic discoveries, we invite you, our fellow explorers, to share your thoughts on the enigmatic Voyager 1 detected in interstellar space, as well as the tantalizing prospects of establishing lunar bases within the Moon's caves. Your insights and curiosity continue to be an invaluable part of our shared cosmic exploration journey. Thank you for joining us on this celestial odyssey. Rest assured, we will continue to bring you the wonders of the universe as they unfold. Stay tuned for more awe-inspiring revelations from the cosmos, because the story of space is far from over, and together we're just getting started.